Hello, everyone. I'm Lee Hongmei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In previous lessons, we have learned about network protocols and network architectures. In this session, we will study the OSI Reference Model. This mini lecture consists of two main parts. 1. The hierarchical model of the OSI Reference Model. 2. The components of the OSI Reference Model. The teaching objectives of this mini lecture are: 1. To understand the concept of the OSI Reference Model. 2. To understand the layered principles of the OSI Reference Model. 3. To master the functions and interrelationships of the 7 layers of the OSI Reference Model. The OSI Reference Model, formerly known as the Open Systems Interconnection Reference Model, is a foundational framework in the field of computer network communication, officially established by the International Organization for Standardization, ISO, in 1984. It not only defines standards for computer interconnection but also provides a fundamental framework for designing and describing computer network communications. The open system refers to the ability for computers of any make to interconnect as long as they adhere to OSI standards. Now, we will study the first part, the hierarchical model of the OSI Reference Model. The OSI Reference Model divides the functions of a network into 7 layers, from the lowest to the highest. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This diagram illustrates the entire process of data encapsulation and decapsulation in the OSI Reference Model. Each layer interacts with adjacent layers through its own protocols and data units. During data transmission, data is encapsulated into specific formats at each layer and then progressively decapsulated at the receiving end to ensure that the data is received and processed correctly. The layered principles of the OSI Reference Model include the following points. 1. All nodes in the network have the same hierarchical levels. 2. Layers at the same level perform similar functions. 3. Adjacent layers communicate through interfaces within the same node. 4. Each layer can use services provided by the layer below it and provide services to the layer above it. 5. Equivalent layers in different nodes communicate through protocols. These principles ensure the flexibility and scalability of the OSI model, enabling interoperability among devices from different vendors. Next, let's continue with the second part, the components of the OSI Reference Model. The physical layer is the lowest layer of the OSI model. It directly connects to the transmission medium and serves the data link layer above it. The basic unit of data at the physical layer is bits. Its tasks include establishing physical connections and utilizing the transmission medium to provide connections for the data link layer. Its role is to facilitate the transmission of information between interconnected systems physically and to transmit raw binary bit streams transparently over the transmission medium. Devices at the physical layer include hubs, repeaters, and coaxial cables. Protocol characteristics include mechanical, functional, electrical, and procedural aspects. The data link layer's basic unit of data is a frame. Its task is to build upon the physical layer to provide transparent, correct, and efficient transmission paths for the network layer. Through data link protocols, it ensures accurate and reliable transmission of binary data. The primary functions of the data link layer include link management, flow control, sequencing, error control, transparent transmission, and addressing. Common devices at this layer include network interface cards, NICs, bridges, modems, and Layer 2 switches. Both the LLC, Logical Link Control, and MAC, Media Access Control, sublayers in point-to-point protocol and Ethernet 802.3 standards operate at this layer. The network layer's basic unit of data is a packet. It is the third layer of the OSI model, responsible for servicing the transport layer and translating network addresses into corresponding physical addresses. It is mainly responsible for selecting the appropriate route, so that the packet sent by the sender can accurately find the destination site according to the address. The main functions of the network layer include route selection, traffic control, transmission acknowledgement, interruption handling, error and fault recovery, etc. Common devices at this layer include routers and Layer 3 switches. The network layer provides two types of services: connectionless, datagram, and connection-oriented, virtual circuit, services. The transport layer's basic unit of data is a datagram. It serves as the interface and bridge between the subnetwork, communication subnet, and end systems, resource subnet. Positioned between the upper layers responsible for data processing and the lower layers responsible for data communication, the transport layer plays a pivotal role in end-to-end communication. Its main functions include receiving data from the session layer, segmenting it into smaller units, achieving end-to-end communication via the communication subnet, establishing and terminating transmission connections, providing corresponding services, ensuring reliable and transparent data transmission to upper layers, and incorporating error control, flow control, and fault recovery mechanisms. Gateways are devices commonly associated with the transport layer. The session layer is responsible for establishing communication between two session users and falls within the realm of inter-process communication. Its primary functions include providing remote session addressing, managing sessions once established, and offering capabilities for reassembling message segments into complete messages. The session layer addresses issues such as providing remote session addressing and session management. It resolves concerns related to session modes, coordination, synchronization, and isolation. The presentation layer serves the application layer and handles data representation issues between communicating entities, specifically dealing with the syntax of user information. Semantic processing is handled by the application layer. Its main functions include syntax conversion, selection of transmission syntax, establishing connections between peer entities within the presentation layer, and managing transmission and release. The application layer is the highest layer of the OSI model, directly interacting with users and serving as the interface between computer networks and end users. It provides various application protocols necessary for performing specific network functions. The functionality of the application layer is managed by corresponding protocols and consists of application programming interfaces, APIs, that provide access to network resources, rather than being composed of actual application software running on computers. Now, let's summarize the content of this lesson. We have learned about the concept and layered principles of the OSI reference model, its components, and detailed explanations of the units, tasks, main functions, and roles of each of the 7 layers. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. This concludes the mini lecture today. Thank you, everyone.